This is a part 1 video of graphing polar curves. So in this video, we're going to look at circles and rose curves. And the lines. Let's start by the most common polar graph, which is the lines. So a line can be represented as theta is equal to A. Theta equals A is going to be a line passing through origin. For example, graph theta equals pi over 3. In this case, this graph doesn't care for what theta is, what r is, what radius is, but the theta is always going to be pi over 3. So this graph is going to look at this. It's going to be passing through the origin and the angle pi over 3 for all the radii. Next, we're going to talk about vertical line. Vertical lines look like r equals a secant theta, or we can say r is equal to a over cos theta. We know from right triangle trigonometry that x is equal to r cosine theta. R is the radius. And now we know that r is a secant theta. So a secant theta cos theta, that would be a over cos theta times cos theta, which turns out to be x equals a. And x equals a is a vertical line, straight vertical line. Now we're going to talk about horizontal line. Horizontal lines look like r equals a cosecant theta, which is r equals a over sine theta, which is equal to a cosecant theta. Now if we know y is equal to r sine theta. Y is equal to r sine theta. If we replace r by a cosecant theta times sine theta, we would be left with y equals a. So y equals a is going to be a horizontal line passing through the point y equal to a. Next, we're going to graph r equals a. So that's going to be a circle with the radius a. Graph r equals 5 would be a circle with the radius 5, centered at the origin. Now, polar graph circles, when we have circles of the form a cosine theta or a sine theta. A circle with the cosine in it is going to be r equals a cos theta will be on the x-axis. R equals a sine theta would be on the y-axis. So a cos theta will be along the line theta equals 0. A sine theta will be along the line theta equals pi over 2. Let's look at a couple examples of graphing r equals a sine theta. So if I am graphing r equals 3 sine theta, I know it's going to be along the y-axis. So that's how r equals 3 sine theta is going to look like along the y-axis. So it's going to be 3, 1.5, 1.5. Okay. R equals negative 3 sine theta would be on the lower side, on the negative side of the y-axis, negative 3, and this would be 1.5. This is going to be negative 1.5. Now we're going to graph r is equal to 3 cos theta. That is going to be on the positive x-axis. So 3 here. This is 1.5. This is negative 1.5. Okay. Graphing r equals negative 3 cos theta will be on the negative x-axis. So this point would be negative 3. And 1.5, negative 1.5. Okay. Now we're going to be graphing polar curves, which are the rose curves. Rose curves are written in the form r equals a sine n theta or r equals a cosine n theta. Keep in mind, if you have a cos theta or a sine theta, that's going to be a circle. But if you have a number in the front of theta, a multiple, then that's going to be a rose curve. Now remember, if n is even, if your n is even, the number of petals will be equal to twice of the n. So if it's a sine 4 theta will have 8 petals. A sine 10 theta will have 20 petals. A sine 8 theta will have 16 petals. So if n is even, the number of petals will be double than the n. If n is odd, number of petals will be same as n. A sine 3 theta will have 3 petals. A cos 5 theta will have 5 petals. And absolute value of a is going to be the max value for the petal. Okay, the max value for the petal, the max y value for the petal, the radius. So what difference does sine and cosine make? For sine theta, or when we're talking about the rose curves, the first petal will occur wherever sine theta is equal to 0, which is going to happen along theta equals 0 for sine theta. For cosine theta, first petal appears along the line theta is equal to 0. For cosine theta, first petal will appear along the line theta equal to 0. For sine theta, first petal appears along theta equals pi over 2. To find the first petal, we're going to let sine n theta is equal to 0 or cos n theta is equal to 1, and we'll solve for theta. Then find the subsequent petals by dividing 360 with the number of petals. Let's look at some examples. So we're going to start with r is equal to 2 cosine 3 theta. So 2 cosine 3 theta, we need to first figure out where is cosine 3 theta going to equal 0. Where is this going to equal 1? That's why wherever your theta is going to equal 1, that's where your first petal is going to be. Sine theta is going to equal 1 when theta is pi over 2. That's why your first petal is going to be at pi over 2. Cosine theta would be equal to 1 when theta is 0. So that's why your first petal is going to be wherever cosine theta is 0, which is going to happen at 0. Okay, so let's see some examples. First of all, I can see my n is odd. That means I'm going to have 3 petals. For the odd n, the number of petals is same thing as n, same as n. Now let's think about the first petal will appear wherever cosine 3 theta is equal to 1. First petal will appear whenever cosine 3 theta is equal to, cosine 3 theta is going to equal to 1. Cos 3 theta is going to equal 1. So let's go ahead and solve it. That means the 3 theta has to be equal to 0. Theta will be 0. So now how many total petals do we have here? We have 3 petals. So 360 divided by 3 is going to give me 120. That means the first petal is around 0 degrees. Second petal is along 120 degrees. And the third petal is along 240 degrees. So that's where my petals are going to be. You can think of it in terms of radians or in terms of degrees. So radius is going to be r equals 2. That's going to be my max radius for my petals. So first petal is along r equals 0. Second is along 120. Third is along 240. So this point is going to be, the theta is 0 and the radius is 2, and this point would be theta is 120, the radius is 2. We write the r first and theta later. 2 0 degrees, 2 120 degrees, 2 comma 240 degrees, 2 comma 240 degrees. That would be the graph of this curve. Next, we're going to graph r equals 3 cosine 3 theta. What's going to be different in this case? Everything else will be exactly same other than the radius, because we still have 3 petals. 3 petals, still the same. We have 3 petals. We still have 3 petals, and we still will have the petals at 0 degrees, 120 degrees, 240 degrees, just like the previous example. The only thing that's going to be different is I'm going to go all the way. The radius would be 3. So this point would be r goes first and the theta goes next. R goes first, theta goes next. R goes first and theta goes next. Okay, that's the graph of the second curve. Next, we have graph r equals 3 cosine theta. So for this one, how many petals are we? First of all, r equals 3 cosine theta. Is it going to be a rose curve? No, it is going to be a circle. Don't be confused when there's no n. There's only one petal, and that petal is going to be your circle. This is not a rose curve. R equals 3 cosine theta is a circle with the radius 3 on the positive x-axis. So circle with the radius 3 on the positive x-axis. It's going to be a circle with radius 3 on the positive x-axis. Okay. And this is 1.5 max point, negative 1.5. Okay, how about r is equal to 5 sine 3 theta? Well, that's when you have n over here, it's going to be, it is going to be a rose curve. So number of petals will be 3 in this case. Number of petals will be 3. So first petal will appear whenever sine 3 theta, whenever your trig part of the function would be equal to 1. That's where whenever your trig part, so whenever your cosine 3 theta is equal to 1, your first petal will appear. Whenever cosine 3 theta is 1, your first petal will appear. Whenever sine 3 theta is equal to 1, our first petal will appear. That means the 3 theta is equal to pi over 2. Theta is equal to pi over 3. my first petal will appear along when theta is pi over 6. Sorry, not pi over, because if I isolate theta, I will be dividing. First petal appears along the line pi over 6. There's 3 total petals, so if I divide 2 pi by 3, each will be 2 pi by 3 apart. So we'll be dividing 2 pi into 3 pieces. So pi plus 2 pi over 3, that's where my first petal is going to be. You can also think about it in terms of degrees if it's easier. So pi over 6 is 30 degrees, and we are dividing 260 into 3. That's 120. So either think about in terms of keep on doing pi over 6 plus 2 pi over 3, another plus 2 pi over 3 to find the location of second and third, or you can think about in terms of degree, 150 degrees, and that would be 270 degrees. That's going to be the location for my petals here. So I'm ready to plot this rose curve. I do have one along pi over 6. The second petal is along 150, and the third petal is along, it's going to be same length. All right, so now what are going to be these special coordinates, special points? Be careful. This is going to be the radius is 5. The angle here is 30 degrees. We can write in terms of radians or in terms of degrees. The radius is 5. The angle is 150 degrees. And radius is 5. The angle is 270 degrees. Right, that's our rose curve here. Let's see another example. R equals 3 sine 2 theta. In this case, for r is equal to 3 sine 2 theta, I'm going to have, this will be slightly, because we have n as even. In this case, n is even. So number of petals, it is going to be 4. Number of petals is going to be 4. Number of petals will be 4. Okay. Now we need to think about first petal appears wherever sine 2 theta is 0. So first petal appears whenever sine 2 theta is equal to 0. Sine 2 theta is equal to 0. That means 2 theta is equal to, sine is a y value, that becomes 0 at pi over 2. So theta becomes pi over 4. Oh, my bad. 2 theta is equal to 1, not equal to 0. Sorry about that. 2 theta would be equal to pi over 2. Sine 2 theta takes on the value 1 when theta is pi over 2. So first petal appears along pi over 4. So if the first petal appears along pi over 4, which is 45 degrees, where is the next petal? So there's going to be 4 total. 360 divided by 4, that's going to give me 360 divided by 4 would be 90 degrees. So each petal is going to be 90 degrees away, starting at 45 degrees. The first one is 45. The next one is 45 plus 90, which is 135. The next one is 135 plus 90, that's 225. This is a 5. And the next one is 225 plus 90, which is 315 degrees. Okay, so let's start this curve, rose curve here. The radius is going to be 3 in this case. Radius is going to be 3. Okay, let's go ahead and graph it. First petal appears along 45 degrees, the next 135, the next 225, and the next one will be 315. Okay, and we can mark the coordinates here. Coordinates at the tips of the roses would be, r is going to be 3 and 45 degrees, 3 and 135 degrees. Again, you can either leave your angles in terms of degrees or in terms of radians. All right, see 2 more examples here. We may not complete them, but let's just start thinking about them. The first one is r equals 4 sine 2 theta. R equals 4 is the radius, I know that, and number of petals here is going to be, number of petals I'm going to have would be, because n is 2, so I'm going to have twice the number of petals. Total number of petals will be 4. So first petal will appear whenever sine 2 theta is equal to 1. When is sine 2 theta equal to 1? Whenever 2 theta is equal to pi over 2. theta is equal to pi over 4. I think the problem we just did also had sine 2 theta. Yeah, so it would be similar. So along 45 degrees, 135, 225, and 315. Pi over 4. So you can also divide 2 pi with 4 because that's what you're trying to, that would be the gap between each petal because you're dividing the entire 2 pi region into 4 total petals. So we can say the first petal appears at pi over 4. The second one would be pi over 4 plus 2 pi over 4. 2 pi over 4 is same thing as pi over 2. The next petal will appear at pi over 4 plus 2 pi over 4 plus 2 pi over 4. So this is your first, second, third. And the last petal will be pi over 4 plus 2 pi over 4 plus 2 pi over 4 plus 2 pi over 4. So let's go ahead and see what is that going to be. First petal is around pi over 4. Second is 3 pi over 4. The third is 5 pi over 4. The fourth is 7 pi over 4. So if you want to stay in terms of radians, you are able to get the petal in terms of radians as well, or in terms of degrees, whatever is convenient or easier for you, or whatever the type of graph you're given. Okay, so these are the locations of my petals, and my radius is going to be 4. So again, this is going to be a curve that looks like this. And these are the angles, and the radius is 4. Let's see our last example. R is equal to 3 cosine 4 theta. That looks like a lot of fun because in this graph, I'm going to be able to, for R is equal to cosine 4 theta, my number of petals will be 8. It's going to be 8, twice of the 4 because it's an even number. Number of petals are going to be 8 here.